Welcome to the world of physics, where students try to understand the concepts and the knowledge of forces and motions that affect the universe and our daily lives.
And with this knowledge, we have been distributed into a group of 7 people to discuss the topic of hydraulics. And for this topic, we have made an excavator which works on the principle of hydraulics. Now, meet the engineers who have made this project possible. Lo Jianhe, Grace, Lim Han Yen, Chan Ket, Chiren, Boon Ket, and me. In the early stages of this project, we have to hold discussions and brainstorming sessions regularly to come up with a project that's exciting.
And the idea eventually came in the form of an excavator. Now, since we see excavators everywhere, but we don't really know how they work, we thought that this was the perfect project. We started on the hardware side first with the small claw, and then moved out with an arm. The arm was then attached to the base, and the excavator started to take shape. We then attached the pipes and the syringes together and attached them to the body, and before we knew it, the excavator has went past its development phase and into its final phase, where everything was done. The project proved to be a success, and this video was made. But enough with how this was made, let's see how it works.
So I will demonstrate to you all how are we going to operate this model. There are 4 strings that control the movement of our project. First, this string controls the movement of the claw. When we pull the string, it will lift up, and when we push it, we can use it to grab some balls. And then this is the second string. It controls the movement of the arm, and it's same as the first one. So when we pull it, it will lift up. So this is the another 2 string is used to control the body of the excavator. So when we push it, it will lift up. Here is an example on how the excavator is used.
Besides that, we have made a mini hydraulic model that demonstrates Pascal's principle. We have placed a magnet here so that we can push it to attract all the staplers on the table. This was made and simplified for children to play. For the project, we have used tube, wooden stick, cable tie, U-hook, and syringes. These are the material we used for this project.
Pascal's principle, which is also known as the Pascal's law, states that in a closed container, the pressure change in one part of the container will be transmitted equally to other parts of the container through this incompressible liquid. So this principle was first stated by a French scientist called Blaise Pascal, where the pressure is equal to the force and the area that it is applying to. So say for example, if I have a hydraulic system where Pascal's principle is being applied on, where the pressure exerted on one piston is applied directly and equally to another piston. So for example, like I have a hydraulic system over here, a simple one made from syringes and tubes and incompressible liquid. So this means that if I have a piston over here and I apply pressure, it will be transmitted through the liquid to the other piston as well. This can be applied to hydraulic systems as a force multiplier as well, where let's say piston 1 has the size of 1x and piston 2 has the size of 2x. This means that a small force applied on piston 1 will increase the force transmitted towards piston 2, even though the pressure is the same. This means that it can be a force multiplier as well and can be applied to hydraulic brakes as well.
Through this project, what we have learned is that teamwork among group members is very important. As everyone will be doing their own part and contribution in this project, and also helping each other when in times of need. Communication is also an important element, as when we are interacting with the kids in the science fair, we have to talk to them with patience and gentle so that they will understand what are we all doing and also understand the message that we want to pass to them.
We have faced a challenge in our group project, as this topic is still considered as a new topic to the kids, and it is hard for them to understand the principle and the concept behind this project. Therefore, in order to overcome the problem, we explain and demonstrate to them step by step to let them understand better. Besides, I think we can improve our project if we had more financial support from our school, as we don't have enough money to buy better materials to improve our product, to make it stronger and better.
So after spending weeks on this project and even having it displayed in the science fair, we have all learned a lot. From teamwork to video editing to physics to hydraulics, we have all learned a number of things. And it's all thanks to this subject, physics, and also you, Dr. Bear. So lastly, I'd like to represent everyone to say thank you for watching our video. Goodbye.